12 years ago. I still teach high school today. I teach chemistry, physics, and a forensics class. So this is like a part-time job for me running this business, but luckily it's seasonal, so we can make it work. But this is older PowerPoint here. I gave it a session up in New York here a while ago. So we've actually been doing this for 4 years now, making these units. And every year we try to come up with bigger and better designs, to bring more customers in. Obviously, we have units now that range from 5 taps to 250 plus taps. So we've come a long way over the years. So overview, what I want to talk about today is what reverse osmosis is, because I noticed a lot of people here are new producers that maybe even haven't tapped yet. So boiling is obviously the most important thing you can do to maple sap, but decreasing the amount of boiling time you'll find is the second most important thing you can do in making maple syrup. So that's sort of the goal of RO. I'll talk a little bit about how it works, why we can apply it to syrup industry, because typically RO is a water purification method, but when sort of used in a different way, a really good way at pulling water out of maple sap. And then any sort of considerations you'd want to make when sizing an RO, and also understanding the boiling process and how RO affects it. A lot of people, some of their first questions about RO is it going to change the flavor of my syrup? And the quick answer to that is no. And research from major universities in the Northeast have all come to that conclusion. But you're going to hear people out there that say it does, and it's not that it does, but it can. If you don't take precautions and do things the right way. We'll talk about that as well. Quick note: this is not a sales pitch, so a lot of the info I give in this, I'm going to relate to my systems, but these are all components you can buy off Amazon. This is just standard commercial and residential reverse osmosis equipment. So there's nothing special about RO in the maple industry. It's all things that have been designed for water purification. So we're just using them in a slightly different way. So what is reverse osmosis? So RO is a method of separating pure water from an aqueous solution. The aqueous solution we're talking about here is obviously sap. Our aqueous solution is sugar and water. And our goal is, before we boil it, to get as much water out as we can so that it doesn't take 40 gallons of sap to make a gallon of syrup, but maybe 20, or maybe 15. Because when you're talking about boiling, even 8 gallons an hour, it's a huge time savings and energy savings in terms of, the fuel you're burning and obviously your time. Unfortunately, to do this, you need high pressures, because naturally water does not just want to leak out of a sugar solution. It's actually the opposite. Water wants to move into concentrated solutions to dilute them. So that's where the term reverse comes from. We're reversing the natural tendency of things in nature to become diluted. So reverse osmosis membrane, this is this year is what's called a TFC, a thin film composite membrane. These are the most popular membranes used in the RO industry, to the maple industry. They're extremely forgiving. They have really good anti-fouling properties, and you keep them moist all the time, and people get several years of use out of them. The driving force here for RO is osmotic pressure. So I'm going to talk about that a little bit. And osmotic pressure is the reason we need to have what's called a booster pump, or a high pressure pump, to pump sap through our membranes. So all these things need to work together in order to get the pure water out. The pressure caused by a pure solvent like water wanting to pass into an aqueous solution, maple sap, in order to make the concentration of both solutions equal. So what that looks like, this is natural. So this is naturally what things want to do. All right, and this is what we don't want it to do. So imagine this is water, pure water, and this is our maple sap, even 2% maple sap, right? So naturally, if I had a semi-permeable membrane that only water could pass through, and I put this in a U-tube like this, water would actually leave the pure water side and enter the sap, thus diluting it even more, making it 1% or 0.5%. Because the natural tendency in nature is to make the concentrations on both sides of this tube equal. And the natural tendency to want to make these equal is much stronger than gravity, right? So gravity is a very weak force compared to the natural tendency for making these solutions equal concentration. The water passes the pure water side into the concentrated solution side to try and dilute it. And that makes the side in this tube go up. So what we can do in reverse osmosis is using energy, right? So applying energy to overcome that natural tendency for that to occur by applying an external pressure, which we're going to use our booster pump to do this. So by using a booster pump, we can press this concentrated side, which might be 0.5% sap or 1% sap or 2% sap, and we can squeeze it through that same semi-permeable membrane that only water can pass through and actually create more fresh water, reverse that natural tendency for water to flow through the other way. But again, it takes energy, and that's why we need a booster pump. And this is sort of the limiting factor in how much sugar we can get in our sap. So there's going to become a point when no matter how much pressure we apply to this thing, the natural tendency for the water to want to flow back the other way is going to be so great that we're not going to be able to effectively concentrate anymore. And at around 120 to 150 psi, you're looking at about 8% sugar. So once you get to about 8% sugar at 150 psi, you can't get any more water to squeeze through the other side. Now, a lot of commercial RO systems run at higher pressures, like 300 psi, and they can concentrate up to 20% sugar. But again, it's going to require a larger pump, more energy to actually do that. So this is a sort of the working model of how reverse osmosis works and how we can offset the natural phenomenon of osmosis. This is very similar to how dialysis would work as well. Stuff like that. It all would fall under the same premise. So a little further into how it works, this is our RO membrane. This is made of a sheet, and this sheet is designed to this sheet is designed to act as a semi-permeable layer. And the key to this sheet is that it's wound up, so we get an enormous amount of surface area. So instead of just a tiny little disc here where water can pass through, we have measured in cubic feet of square feet, sorry, of area to push water out. So that makes this process go a lot faster, and that's why it's really important to choose, an RO membrane that has a high gallon per day rating. So if you look at them, they'll have like 50 gallon per day or 75 gallon per day. The ones we use are 400 and 500 gallon per day. So that rating is going to pertain to the way the sheet is made and how many windings it has. And the more windings it has, the more surface area you're going to have to put water. And water eventually will collect in the central tube and exit out the center, which we call that the permeate or pure water. So if you hear the term permeate a lot, that's the water you're taking out of the sap. And then you're left with concentrate, which is usually called reject water in a traditional RO system. So we're saving the reject water because that's now our concentrated sap, and that has all the sugar in it. It also has all the ions and stuff. That you're concentrating as well. And it also concentrates all the bacteria, which is why RO'd sap doesn't last as long, because, the density of biological matter is much higher after you concentrate it and take out, all the water that was diluting it before. So how does it work? This is a little more technical. So osmotic pressure, this is the key here, and osmotic pressure is a function of these variables. So the only variables we're concerned with in this equation are molarity, which is going to translate to the percent sugar, and temperature. So if we want an efficient process, we want to try and keep this osmotic pressure as low as possible. The lower the osmotic pressure, the less pressure I'm going to need from my booster pump to separate the sugar from, to separate the water from the sap. And lowering osmotic pressure is going to mean that I need to concentrate to a lower percentage of sugar, or I need to maintain a lower temperature. So we have a couple things working for us and a couple things working against us. Obviously, for sugar percent, as we run our RO, what happens to the sugar percent of the sap? It goes up. That's going to increase the osmotic pressure, which is why over time, the system, as you're processing, the system is going to slow down, because as the concentration of sugar goes up, the osmotic pressure goes up. So the differential pressure between, our booster pump and the osmotic pressure of the system is going to make it the water come out at a slower rate. We don't really have any control over that, but in a sense, if you concentrate to 4 or 6% with these smaller systems, that's not really going to be a big issue. But the other key here is temperature. And luckily, as temperature goes down, osmotic pressure goes down, and our systems run at 32 to 40 degrees Fahrenheit, so relatively cold. So that's advantageous because those cold temperatures keep the osmotic pressure a little bit lower in the system, so we can concentrate to a higher sugar percentage, 6 or 8%. So if you were to run an RO system at 32 degrees, you could probably, let's say you could get up to 8% sugar. If you were to run that same system at 60 or 70 degrees Fahrenheit, you're not going to be able to achieve those higher sugar percentages. It's not going to be able to go as high. You might only get to 5 or 6% because the osmotic pressure is greater. You could overcome that by increasing the pressure in the system, but most of the time, that's maxed out at 150. You can't really go much higher. How does RO work? What does it all mean? So high pressures allow for a maximum sugar concentration. So high pressures, the limiting factor there is going to be the booster pump selected. Most are going to go between 120 to 150 psi. Cold sap is going to achieve a higher sugar concentration. And this is the general rule, a volume of sap. This has changed a little bit, so this number isn't exact. There's a good YouTube video on the rule of 86, but generally speaking, 2% sap is about 40 gallons of sap to make a gallon of syrup. So what can you achieve from RO? Time savings. Any water removed using RO will not have to be boiled. Even if you have an evaporator that can boil 20 gallons an hour, having an RO that can process even 5 gallons an hour is still advantageous, because when you run your evaporator, you have to put fuel in it. You have to sit there and babysit it to make sure it doesn't scorch. It's a very hands-on process. RO is a very hands-off process. It's a passive process. Requires much less energy than running an evaporator. You're talking 75 watts of electricity, at 12 cents a kilowatt hour. So virtually no money in electricity. And you're removing water when you don't have to sit there and watch it. So, the time savings are tremendous because you can start it up, 8 hours before you boil, walk away, come back, and end up having, a large amount of concentrate ready to go in your pan that you don't have to, watch all the water come in. Cost savings, again, in terms of fuel savings, because it's much cheaper to pull water out without boiling it. Energy savings, and then a higher quality product. And some will argue that you do not get a higher quality product from RO, but I would argue that you do, because I think for most small producers, after they boil, they're just kind of done. They spent so much time boiling and they just want to get picked up quick. And I think the most important parts of finishing syrup are when you get it to the 66.7% sugar and you clean your bottles really well and you pack it hot and you take your time when you do that. And I think, unfortunately, we're so tired out after boiling that we rush those extremely important steps. I think for small producers, having an RO and speeding up the boiling process gives us a little more time to focus on the things that we often overlook, the really good boiling practices. So I think for the majority of people, you're going to end up with a much higher quality product. And also, using RO, you get a lot more flexibility on the different grades of syrup you make. Generally, RO is going to give you a lighter colored syrup. The ones we're using that don't heat the sap a lot because we're not going to that high of a sugar percentage. So you're going to start with a lighter syrup, and you can just keep adding concentrate to that to achieve the color grade of syrup that you want. So let's say you finish a batch and it's a little lighter than you wanted. You can just add more concentrate to it and keep boiling it at 50 to 55% sugar until you achieve the color profile and the flavor that you want, and then you can stop it and bottle. In terms of cost savings, this is just a little chart I put together. So for a typical backyard sugar who can do 8 gallons per hour, which is probably like a 2x3 flat pan or 2x4 flat pan, which a lot of beginners are using, and assuming 4% concentrate from 2% sap, so one pass through simple RO. Traditionally, to make 5 gallons of syrup, you would have to boil for 25 hours. And obviously with an RO with a single pass, it'd be 12.5 hours. So this just shows you the time savings from running a single pass. And keep in mind that you're not limited to 4%. You could go easily do another pass up to 6% and see a larger savings in time. And again, that's just going to depend on how big your RO is and how much time you have before you boil to run it and get concentrate taped up. A lot of our customers run 2 passes up to 8%, so they're going to be cutting it into a quarter, you know. So you're going to see a similar thing with cost savings. This is a analysis done with wood and propane. Propane costs of $2 a gallon is what I used. Most people are running them off those smaller tanks. So you can see cost savings for wood or propane with a single pass. You know, if you're making 30 gallons of syrup a year, obviously it starts to add up. So in conclusion, you know, if you make 10 gallons of syrup a year in a 2x4 evaporator, you're going to save 13 hours of boiling time, $67 in fuel costs, and you're going to double, or you could double your syrup production, which is really where the money comes in, you know, because you know, $67 in fuel costs is really nothing if you're making 10 gallons of syrup. It's $60 a gallon, right? That's $600 of product you can sell. So instead of doing these two things, you might be better off just adding an RO, keeping in the same infrastructure you currently have, doubling your syrup production, which will give you a $1,200, you know, $1,200 market value. And again, that's going to depend on whether you have the trees to do that. You know, otherwise you're just gonna, you know, you'll have the added benefit of reducing the boiling time. I think most people that make an RO or buy our systems think they're going to save time and fuel, and they just end up getting bigger because that's what we all do in this industry. You know, we start small and eventually everybody has 100 taps and then 200 taps, and then we either plateau because we don't have any more trees, or we just keep building up from there. In terms of your options, what you can do, you know, you can buy a system already made like ours, or you can, you know, easily buy the components and make a system yourself and have a perfectly, you know, working RO system. So we're going to focus on hobby size systems today. These do exist as well. There's mid-size ROs for up to 500 taps. They usually run $1,500 to $3,500. And they use this really typical 4x40 membrane, which is really common in the maple industry. The 4 inches wide by 40 inches long is what those measurements are. And then there's also 8-inch membranes and whatnot when you get to really large systems, and they're, you know, $3,500 all the way up to, you know, $100,000 and more. So we're going to be focusing on the hobby size ones today. I'll just run you through quick the different things that can be used to make these. So what you want to consider is how big of an RO do you really need, how much time you want to spend, how portable it needs to be, and how easy it is to use. You know, how big does it really need to be? You always want to remember that you don't have to run this while you're boiling. You know, a lot of people come into it thinking that their RO has to match their evaporation rate. So if they can boil 8 gallons an hour, they need an RO that can make 8 gallons of concentrate an hour. And you really don't need that, because you can run this, you know, for 8 hours the night before and get concentrate made up. And then you can sort of save a little money by not having to have this huge piece of infrastructure, you know, that's really expensive when you're only going to use it, you know, 10 times a year. So, well, the different things you can use to make these are, you're going to need a membrane housing and membranes. And let me see here. Yeah, so I'll run you through. I forgot when I did this the last show, I ran you through the actual unit. So what you're going to need when you do this is different components. I just switched to my web page. Can you guys see that? Okay. So if you go on my webpage, I actually have schematics that apply to our systems, but you can actually use these if you wanna make a system yourself. So I'll just pull up our RB15 schematic here. So this tells you all the different fittings you're gonna need to put an RO together, and then it tells you all the components. So the first thing you're gonna need is a booster pump. And one of the most common booster pumps used by people building these is the Aquatech 8800 series. It's a really good pump. It has a really good suction. So you don't need a pump before it. It can actually draw out of a barrel. We use this very similar diaphragm pump, and they're usually rated in gallons per day. So like an Aquatech 8800 is a 100 gallon per day booster pump. We have booster pumps that go from 400 gallon per day all the way up to 800 gallon per day. So that's sort of the most important part of your RO system, and probably the most expensive. You're usually going to pay around $120 to $300 depending on how large of a booster pump you use. And then obviously you're going to have an intake hose coming into that, and then your output hose. And these usually run off 24 volts DC. So it'll come with a transformer and you can plug it into to a standard wall outlet. Pressure gauges are optional. Then it's going to go into a pre-filter, 10-inch pre-filter housing, that's a standard water filter housing. So just like you'd have in your house, they're either clear or they have a, like a blue cap on them. And you're going to have a 10-inch pre-filter in that. So that's the second thing you're going to need. Then you're going to need your RO membranes. And you can either run one or you can run several in series. And this particular one, this is our RB15. So on this one, we run 3 400-gallon per day membranes in series. So you can see the sap comes in the top, and then the water, the H fitting there is a T. So these are all the D fitting there. These are all our water fittings that all get teed together. So all the water fittings are teed together, and we just run the concentrate from the first membrane into the second membrane, further concentrating it more. And then we run it from that one into the third membrane, further concentrating it more. And you can keep doing this over and over and over until you reach the limit of your booster pump. So a booster pump is only going to be able to handle so many membranes. And once you go past the number of membranes the booster pump can handle, the pressure is going to drop. You're not going to be able to maintain pressure in the system. And then you're not going to be able to overcome the osmotic pressure. So then you're not going to be able to pull out triggers effectively. So that's how that works. We use as a general rule in terms of flow rate, because a lot of people want to know like what the system will do. A single 400-gallon per day membrane will be able to process 8 gallons of sap per hour from taking 2% sugar to 4% sugar. So one 400-gallon per day membrane can do 8 gallons per hour. That's sort of the rule of thumb. So this RB15 has 3, so this can do about 24 gallons per hour. If you look through if you want to take a look through our schematics, like we have an RB25 now that has 5 400-gallon per day membranes. Again, that's going to have a larger booster pump. So all these parts can be sourced on Amazon. We sell all these parts on our website. If you guys ever have questions and you want to build your own and you run into some trouble, just shoot me an email. It's not a big deal for me if you want to build your own and you need help. I'd be more than happy to help you. You don't have to buy my components, but a lot of people come to me because theirs doesn't work. A lot of these fittings at the base here are reversed on different manufacturers. So the water port's on the left and the other port's on the right. So that kind of trips people up a lot. But yeah, feel free to reach out and let me know if you have any questions. There's a lot of videos also on my website related to testing permeate water. So if you go to our videos section, I have a video library that has informational videos and product specific videos. So like testing the performance of your RO membrane is what I did last year. So throughout the season, using a TDS tester, what they talk about in the video, you can tell if you're flushing your system well enough and how well your membrane is performing. So this is a really good way to learn a little bit more about RO because I'm running out of time here. So here's 3 systems we sell. Again, just talking about the flow rate. So our RB5 has 1 membrane. Our RB10 has 2 membranes, and our RB15 has 3 membranes. So these are 3 systems that we make in a bucket in addition to our kits. And then we sell kits you put together yourself. So I hope I didn't sort of rush that too much at the end there, but I was keeping track of time. So if you have questions, visit our website or shoot me an email at sales@therobucket.com.
Hey, Carl, we actually do have some time for questions if you're willing to take a few. And
sure. I'm good to go until you cut me off. So
somebody asked, how do you reuse the resultant water, or do you reuse the resultant water?
Yeah, so the majority of your permeate water you really are not going to use. You always want to save like 10 gallons of water to flush your system per membrane that you're using. So if you have like 2 membranes, save 20 gallons to flush it. If you have 3 membranes, save 30. Some people save twice that. Really you can't flush the system enough. I think the main issue most new people have with a new RO is that it doesn't get flushed enough and it starts to get a little stinky, and then they have to run chemicals through it like a RO soap rinse to get it back again. So being really proactive and flushing it really well after every use and keeping it as cold as possible without freezing is really going to save you a lot of time throughout the season. So yeah, so to answer your question, your permeate water, I mean, you could technically drink it, or do anything else you would with pure water. But yeah, the majority of it, you really don't have a use for, and then you just got to put some aside to flush your RO system. So.
Carl, I'll share that we had a person, a syrup producer with about 1,500 taps. He's in Kentucky, and he started bottling that permeate and selling it, I guess, as purified maple water. You know, he got a permit, you know, had to go through a process. But
Yeah.
it's kind of the health crowd, I guess. You know, wanted to.
Yeah, definitely. You know, and the thing is like it sounds marketable, but you know, really it's really just distilled water. You know what I mean? There's really nothing in it. Like the RO process is such a clean process that you know there's no residual sugars in that RO water. There's virtually no ions in it. You know, so yeah, it's a really clean product. I know like Wegmans for a while. Wegmans was just bottling purified sap, like 2% sap, and selling that is a product. We have, I don't know if you're familiar with Wegmans, you're probably not, because it's up in New York, but yeah, you know, so that's the thing. Our maple water, there's a lot of different types of maple water. Like you said, some people just sell RO from maple, which is really the least maple of waters. And then there's maple sap, and then there's maple sap that's been RO'd, so it's even sweeter, you know, that people sell as maple water that's 4 or 6% sugar. And that's the stuff that tastes really good, obviously.
Yeah. And I think Tom touch on a little later on alternative markets for sap, so that should be an interesting.
Yeah.
And there's some other.
They have like Hybrix ROs now that they can make like almost syrup level sugars, like 50% sugar, and they're not using that as like a way to make maple syrup because you know it doesn't boil and there's not enough time to get flavors out, but they're using it as like an extract as an artificial sweetener. So yeah, they're trying.
So I think I accidentally muted you there, Carl. I'm sorry. I was juggling several buttons at once.
Yeah, so they just want to, you know, they want to try and use maple sugar more in you know the cooking industry and have a better platform to sell it. So just selling a 50% concentrate mixture is, you know, could be good for us because we could just RO it and sell it and not have to make it into syrup. And you know, we already have the infrastructure for all the tapping and stuff. So if we develop markets for this stuff, it'll really help everybody out. I think what you're going to find is a lot of these commercial producers are going to move away from the syrup, meaning that us smaller guys will have a better, you know, maple syrup industry, and they'll be selling the concentrate, you know, to use as a sugar substitute. So it could be good for everybody.
And there was a question: how long does a filter last, and how do you know when it's time to change filters?
Yeah, so the RO membranes last several years, and you'll know when to change them if you look at that video on testing your permeate water. So basically, the quality of your permeate water is what determines when your membranes need attention. The pre-filter, they're relatively inexpensive. Like we sell them for $2 a piece. I usually recommend people run 300 to 500 gallons of sap through it. And if you're only going to use like 50, if you're only going to run 50 to 60 gallons through it, I would take it out and store it in the refrigerator between uses and then put it back in. And then you can use it a couple times. But, you know, generally, you're probably going to run a new one every time you use the machine, you know, every time you plan on firing up the RO. Because before you flush it, you want to put a new filter in so that you don't flush all the contaminants through your system. That way you're running it through a clean filter through the system.
Okay. Kind of along those lines with cleaning, there was a question: how do you clean the entire system so it don't get kind of messed up during the off season?
Yeah, so I'll run you through. So basically, this is what I do, and it's pretty fail proof, and I think most of our customers do it too. And they get away with only running the chemical, the RO soap, once at the end of every year. So what I do is if I process X number of gallons, it's 200 gallons, I save a barrel. I always have like one of those blue plastic barrels full of water, and then it just overflows, and I just let it go. So when I'm done, the first thing I do is I run 10 to 15 gallons of permeate water through the RO before I do anything, before I change the filter or anything. After I run 10 gallons through it, I take the old filter out, the $2 pre-filter. I put a new pre-filter in, and then I run another 20 to 30 gallons through it. And then I just leave it until I'm ready to use it again. And if you do that, you're good for like a week or two if you do that. So the key is that if you keep using it every week, you can get through the whole season without running any chemicals through it. The problem is when it sits for 2 or 3 weeks. If it's going to sit for 2 or 3 weeks, you really need to put like an RO soap, but you got to get the pH up to keep the bacterial growth down. That's really the most important thing. So, but if you're freezing up and you're not going to use it for a while, I would recommend instead of using chemical, just every 4 or 5 days, run 10 gallons of water through it, like well water, and that's just going to keep you going again for another 4 or 5 days. So as long as you keep a flux through the machine throughout the season, you don't really have to put any chemicals in it. You just don't want it sitting there stagnant, or it'll start to get funky. That's all.
Okay.
And you got to watch out. You can't put chlorinated water through it. So if you're on a municipal water source that's chlorinated, you'd want to run like a carbon block pre-filter, or you could run 10 gallons of water into 5-gallon buckets and leave it out for a couple days and then use that to flush. So, there's ways to get the chlorine or chlorine out, but you just don't want chlorine to come in contact with the membrane. So.
Okay. And this question I know is from a commercial producer. He asked, if you start off with a smaller RO and increase your numbers of taps in a couple of years, can you expand that system?
Yeah, so we've made our RB10, our 2-membrane system, expandable to a 3-membrane, and now we have a new 4-membrane system that's expandable to a 5-membrane system. So yeah, they are expandable, and again, that depends on the booster pump, but I would say, like, if you get an Aquatech 8800, which is like the most common sort of homemade DIY RO pump for small producers, you really can't run over 600 gallon per days of membrane on that. So that's kind of your limit. So.
Okay. There's a question: have you experimented with UV before the RO filters to help control bacteria?
Yeah, we I have RO kits. I mean, I have hundreds of RO units, and I don't even sell them anymore because I just haven't seen a really good effectiveness from them. The problem is if you put it before. So the problem is if you put the UV before on the intake side, the flow rate's a little too high, and it can't kill the bacteria because there's just too much flow. And if you only try and UV or concentrate, which is half as much, so you think it'd work better. The problem is it comes out of the membrane so turbid and cloudy that there's just very little penetration to kill bacteria and microorganisms, and the contact time still isn't there. So, I mean, I'm sure it probably doesn't hurt. It's not going to hurt anything, but I think for even the cost of, I think I sold them for 50 or 60 bucks. I mean, I don't know. I just kind of felt bad selling them to people without talking to them in person and telling them, the deal on it. Like, I don't want them to think that, they could get it and their sap would last 2 weeks. It's not going to happen, but certainly you could UV or permeate water if you wanted to save that and drink that. That would be a good thing to do, because the permeate comes out relatively clean and not cloudy. So that would be it would be much more effective to UV that than it would be to UV your sap. But yeah, that's a really good question.
Okay. Another one: does RO affect production of sugar sand?
No, RO doesn't. Sugar sand comes from like precipitated calcium nitrate and stuff like that, and all that gets concentrated in the sap. So it doesn't decrease it, it doesn't increase it. An RO system working effectively is not going to pass any calcium nitrate out the pure water side. So it's not going to decrease your niter, and it's not going to increase it because it's not just making these ions out of nowhere. So it's not going to have any effect on it.
Okay.
Much like, pre-filtering sap doesn't decrease niter either, because at that point, all that stuff is soluble in the sap, so it doesn't have any
effect. Okay. There's a question: is the permeate water similar to distilled water?
Yeah, distilled water has a 0 TDS. Our systems generally run 5 to 6 parts per million, or 5 to 6 total dissolved solids. So you're basically as close to distilled water as you can get. If you we actually sell not activated charcoal, but ion can't even think of the name. But the ion activated ion cartridges for people if they want to get their permeate TDS to 0, like for an aquarium or something like that, because we sell aquarium units. So there is a need for permeate water that's sort of polished, so to speak, and to get those residual 5 or 6 part per million ions out. And then that is comparable to distilled water. So
Okay.
RO water with the addition of an ion exchange resin is typical of distilled water. So
Okay. And there's a comment here, and this might play into Tom's presentation later, but somebody commented that Walmart lists maple water in 12-ounce bottle, and a pack of 12 is $29.88. So that's definitely
nice.
a high value product.
Yeah, definitely market there.
There's a question: what micron size do you recommend for the pre-filter?
Yeah, 5 micron is really 5 micron is the standard. You know what? I use 1 micron sometimes. We had some supply issues last year with COVID because all that blown polypropylene was being used for masks, and it was hard to get pre-filters for a while. So we were using 1 micron, but there's no difference between 5 micron or 1 micron. To be honest with you, it's not, 1 micron aren't gonna plug faster, and five micron aren't gonna follow your membranes out. You know, there's a lot of talk of like fouling membranes and filters getting plugged. In my 4 years of selling these units, and I sold a lot of these units, I've never had a person plug a pre-filter. You know, pre-filters usually get ditched because they get smelly and you know they get biological growth. You know, we just don't put enough sap through our pre-filters to plug them. You know, those things are made to run thousands and thousands of gallons of water through before they get plugged up. And for most of our sap is pretty clean coming out of the tree. And yeah, you know, so I guess that's kind of my take on it.
Okay. Well, thank you, Carl, very much. And if I miss somebody's question, I apologize. But right here is the email to get in touch with Carl and to get more information about the RO bucket. He's got his website up, so I'm sure he doesn't mind if you shoot him a
Yeah,
question.
no, not at all. And also on if you go to Facebook, there's a lot of Facebook groups for people, and I'm sure a lot of people know about them. But that's a great place to get info. I started a RO Bucket Information Exchange. It's called. If you search that, that's a new group of customers and people looking into DIY RO to ask technical questions about their setup and troubleshoot why things may not be working. So that's a good place to look to if you guys have any questions. So
Okay. All right. Well, thank you very much.
yeah, thank you for having me.